There is a need to redraw the mechanical system shown to illustrate the relationship more clearly. The redrawn mechanical system with the relationship more clearly illustrated is as given. It is important to note the existence of dampers between M1 and M3, which is drawn, therefore a damper between M1 and M3, B2 between M2 and M3, and as well as B3 between M3 and the reference. Let the movements of the system be V1 associated with mass 1, V2 with mass 2, and V3 for mass 3. Considering the force relationship for mass 1, we have Fk1 minus Fk2 minus Fb1 will be equals to 0. In the case of mass 2, we have Fb2 minus Fk2 is equals to 0. In the case of mass 3, we have F minus Fb3 minus Fk3 minus Fb1 minus Fb2 is equals to 0. We next tabulate for the mechanical element, mechanical flow, electrical flow, and electrical element. All the mechanical elements are listed down as follows. The mechanical flows associated with the mechanical elements can be easily determined, and they are given in this column. With the mechanical flow determined, finding the electrical flow equivalent is a very simple procedure. Finally, we relate the electrical element to its analogy in the mechanical element, wherein the force is associated with voltage, the spring to a capacitor, a damper to a resistor, and a mass to inductor. We next proceed to create a sketch of the electrical system. If we consider the elements associated with current I3, we find that there is a voltage source, a capacitor, resistor, and inductor involved. Hence, in the sketch for the flow of I3, we have V, C3, R3, and L3. In the case of the current I1, two elements are involved, the capacitor C1 and the inductor L1. Hence, for a current flowing out from this node I1, it passes through C1 and L1. In the case of the current I2, it passes through the inductor of L2. Hence, in the sketch, the current I2 passes through L2 as shown. The current I3 minus I1 passes through a resistor R1. Hence, from this node, the current I3 minus I1 passes through R1 as depicted. For the current I2 minus I3, the element that it passes through is R2. Hence, in this sketch that comes out from this node, the current I2 minus I3 passes to R2. The last current flow, I2 minus I1, passes through an electrical element C2. if the top node is connected back to below, such that it meets this node here, the current I2 minus I1 flowing into it will pass through the electrical element C2. The simple electrical sketch then allows us to construct the more complete circuit as shown. Here we can see that the mesh current I1 flows through this loop, I2 for this loop, and finally I3 for this loop. Again, there are three meshes associated with three mechanical equations of motion.